Welcome to a quick, easy quiz on refraction of light from school physics. This will be found to be immensely useful for middle-level students. Instant recall and application of fundamental physics concepts. Easy, stimulating, motivating, interesting. There are 6 questions. Take a sheet of paper and a pencil and write brief answers or select the option for each question. At the end, we will give the answer and the explanation. So, let's go. Here is question number 1. Look at the figure. A ray of light passes through a glass slab of uniform thickness. The lateral shift refers to the distance between the incident ray and the emergent ray. Now, in reference to the lateral shift of the light ray, select the correct option. You have 5 options. The lateral shift xy depends on option A, thickness of the block, T. Option B, angle I. Option C, angle R. Option D, all of the above. Option E, none of the above. Just write question number 1 and your selected option number. Here is question number 2. In the figure, xy is the lateral shift of a light ray after passing through a glass slab. The question is, what should be the angle of incidence to make the lateral shift 0? The dimensions of the block and the color of the light ray will remain the same. So, write the value of angle of incidence so that xy is equal to 0. Just write question number 2 and the value of angle I. Here is question number 3. Look at the figure. The diagram represents a ray of light traveling from one transparent medium to another transparent medium. Now answer the following 4 questions. Question A. Name the phenomenon exhibited by the ray. Question B. Which medium, 1 or 2, is optically denser? Question C. In which medium, 1 or 2, is the speed of light greater? Question D. Name a condition, other than the relative optical densities of the media, for this phenomenon to occur. Write brief answers for each question. Here is question number 4. This is about the refractive index for turpentine oil. Which value can possibly be the refractive index for this organic liquid? Option A, 1.00. Option B, 0.8. Option C, 1.46. Option D, none of the above. Option E, all the above values are possible. Write question number 4 and your choice of option. Also, give a one-line reason for your answer. Here is question number 5. Look at the figure. A ray of light, passing from medium 1 to medium 2, bends in a certain way. You have to identify which is denser medium and which is rarer medium. Is the substance 1 denser than or rarer than substance 2? Give a reason for your conclusion. Write question number 5 and the brief answers. Here is the last one, question number 6. Look at the figure. A ray of light, passing from medium 1 to medium 2, bends in a certain way. If the refractive index, 1 mu2, is 1.5, which of the following about the ray of light is false? Statement 1. Ratio of sine angle I to sine angle R is equal to 3:2. Statement 2. Ratio of wavelength in substance 1 to wavelength in substance 2 is equal to 3:2. Statement 3. Ratio of velocity in substance 1 to velocity in substance 2 is equal to 3:2. Statement 4. Ratio of frequency in substance 1 to frequency in substance 2 is equal to 3:2. Only one statement of the above 4 is not true. Identify it. Write question number 6 and your choice. Didn't you find all these questions easy and elementary? Here are the answers with explanation for you to check, though we are sure that you have got all the answers right. Check the answers and also see the explanations. Answer to question number 1. The formula for lateral shift is shown. Even if you didn't know this exact formula, you have learnt that the lateral shift depends on angle of incidence, angle of refraction, and the slab thickness. Angle of incidence and angle of refraction are connected by the value of the refractive index. So, the correct answer is option D. Lateral shift depends on all the given factors. Answer to question number 2. For the lateral shift to be 0, the incident ray, the refracted ray, and the emergent ray, they all must be in one straight line. For this, the ray should be normal to the glass slab surface. This means that the angle of incidence is equal to 0. Answer to question number 3. The phenomenon is total internal reflection, as the ray doesn't go into the other medium. Total internal reflection requires that a light ray must pass from a denser to a rarer medium. So medium 1 is denser. If medium 1 is denser, then the speed of light will be more in medium 2, which is rarer. The other condition for total internal reflection is that the angle of incidence must be greater than the critical angle for the pair of media. Answer to question number 4. The refractive index cannot be 1. Because it is 1 only for vacuum, for all other substances, it is lower. The value 0.8 is absurd, as refractive indices are never less than 1. Refractive index below 1 would imply that speed of light in the medium is faster than the speed through vacuum, which is never possible. The value 1.46 is perfectly valid and possible. So, the correct option is 1.46. Answer to question number 5. Because the light ray bends towards the normal, medium 2 is denser than medium 1. Angle I is greater, so light speed is greater, which means it is a rarer medium. Angle R is smaller, so light speed is lower, which means it is a denser medium. To remember this, note that the greater angle of the light ray with the normal means the greater is its speed and hence lower is the optical density. Answer to question number 6. When a ray of light passes from one medium to another medium, the velocity and the wavelength would change. But its frequency remains constant. So, statement 4 is false. Frequency is always unaltered.